Hi, I'm Neha. I'm an iOS engineer at Plenty of Fish. And today I'm excited to talk to you about advanced colors in iOS. So color is a fundamental and important aspect of app development. It identifies brand and evokes emotions. It also teaches us whether a button can be touched and a switch can be turned on or off. It's an important observation that most of the pixels that you see on the screen do not come from images. They are the solid colors drawn by the code in your application. In the last few years alone, Apple has introduced new technologies which make it worth revisiting how we approach colors in our apps. So first, we will talk about semantic colors and, if implemented well, how they can improve the time spent on updating colors. Then we will talk about common problems we face debugging named colors, how we can namespace the named colors, and how to deal with dynamic colors. And lastly, some of the collaboration techniques between designers and engineers. But first, let's talk about an important problem. So, color specification is definitely an underappreciated problem. Usually, when designers and engineers communicate among themselves, the color code is usually communicated with assumed sRGB color space. Now, if this sounds familiar, you must have seen something like this. RGB, 128, 45, 56, very simple. This doesn't tell you what the color space is, but it is assumed that you know what that color is. Because everybody's using its RGB, aren't they? Well, not anymore. So this is no longer sufficient for working with wide gamut colors. All iPhones prior to iPhone 7 only represent colors in sRGB color space, whereas newer Apple devices like iPhone X use bigger color space that covers wider gamut of colors. But what are wide gamut colors? So P3's color gamut, which was introduced in iOS 10, is about 25% larger than sRGBs. And it supports colors that fall outside of sRGB color range. There's a very nice WWDC talk about working with white colors, which provides excellent explanation on this topic. So, do you need to be concerned about this? A simple answer is no. In order to bridge the difference between the devices that support either of these color spaces, starting in iOS 10, the UI color class uses the extended sRGB color space. It supports a wider range of colors while implementing the backward compatibility to ensure that older apps still function. OK, so what is the takeaway? So the most important step is to be specific about the color space and use P3 color space when you're working with wide gamut colors or designs, and indicate as such. OK, let's talk about another problem, picking colors. We are talking very basic here, but it's very important. We just saw how to communicate the color, but where did the color actually come from in the first place? You probably picked it using a color panel. Now, this is a standard color panel that gets shipped with every Mac, called as NS Color Panel. Now, this is obviously a familiar UI, but it also suffers from the same limitations that we just talked about calling colors. So typically, you pick red, green, blue, 0 to 255 numbers. But selecting the color space hasn't always been an easy or intuitive user experience. So Xcode doesn't readily show you the selected color space. It's off in a side menu. This is because Xcode Color Picker treats the color space as a viewing preference rather than a component of the color. Let's look at this example. So the problem is represented here. I choose a color in a sRGB color space, and I realize that this is not the color I want. So I change my color space to P3, and in order to keep the colors same, Xcode updates my RGB values. So essentially, I have to do my first step again. I have to re-enter my RGB values to get the right color. So now this is obviously not a desired user experience, so always choose your color space before entering in your color values. Okay, moving on. Let's talk about dark mode. Nowadays, everybody is using dark mode. That's Game of Thrones in dark mode. Just kidding. So Bloomberg published an article stating that iOS 13 will have a dark mode that can be enabled via control panel of your iPhone. And since iOS dark mode is a big deal, it makes semantic colors all the more important. Let's talk about how we can leverage semantic colors to support the dark mode in our app. I'm kind of building up on Alina's talk here, in which she nicely demonstrated how to support dark mode at the code level. Okay, what are semantic colors? Semantic colors are colors with a meaning. Semantics in the color names help us visualize the meaning or the value state of the color. Let's look at some examples. Do they look like semantic colors to you? No. These look like more like the color names which are like indicative of the color's hue. This helps in distinguishing between colors in our palette at a glance. These are also known as declarative colors. Now, this is an example of semantic colors. These colors do add a meaning to the underlying colors. In this case, they indicate the primary text color and destructive button text color, respectively. Now, this is another example of semantic colors, but probably I went too far in naming them. Now, this is like too specific. So depending on how granular you want to get with naming your color assets, you will end up with a number of semantic that point to the same underlying color. This is normal, and it doesn't mean that you have to consolidate this duplicate semantic, because you want the flexibility to change these unrelated colors independently. In general, I recommend being as generic as possible unless required to be specific. So as you can see from the about screenshots, although my colors for the dark and light modes have changed, the semantics for the colors are intact, which essentially means I have to change or introduce no code while changing my themes. This can also be extremely useful when you are A/B testing colors. Semantic colors really shine when combined with named colors to support these kind of theme changes. By creating a semantic color system, you are creating an abstraction over your declarative colors, which makes it easy to experiment with color palettes without worrying about specific code changes. It makes drastic redesigns easier to plan and less painful. Creating semantic colors does not mean incrementing the number of colors, but rather distributing your colors using semantic references. Okay, so some of the things to keep in mind while designing your color system. You don't want to be checking the global file anytime you have to pick a color. So keep your color variables easy to remember, name them with easy to remember names, and make them intuitive. You will add, remove, and rename colors. Make sure doing so is not complicated. Now, this one we have heard so many times, yet we always end up with more colors than we need. The real success key to any system is removing all that is not necessary. Traditionally, our iOS app at Plenty of Fish, we do a lot of experiments. The average time spent on the color experiments until we implemented the Semantic Color system recently ranged from half an hour to like 1 week. After we redesigned our system to include and use the semantic colors, it got drastically reduced, as we simply had to make our code point to a specific color palette. Okay, just to get an idea, how many of you are using named colors in your apps? Okay, that's a lot of them. So I know for a fact that many developers are still not using named colors for various reasons. We're going to take a look at some of the basic problems that we face while debugging named colors. So named colors were introduced as one of the minor but intriguing features of iOS 11 SDK, which received almost no on-stage attention. This feature helps developers save time and avoid mistakes by organizing project colors in a single location. The immediate benefit of named colors is quite simple. Being able to change colors quickly and comprehensively, and being able to synchronize color definitions across code and interface builder. I learned some things while using the named colors that I would like to share with you. When I started using named colors, I defined the named colors in an asset bundle. And the consumer of these colors was our reusable UI component library. When I tried using these colors in my consumer library, I couldn't access it. Why did it happen? Just how UI image named works in iOS apps, the main bundle always takes the precedence unless specified otherwise. So that's the only place where your app looks for resources. I'm sure most of us who have used named colors came across this problem sometime. So on the code side of things, there's an easy fix. Whenever you call UI color named, simply ensure that you set the optional bundle parameter. If you're looking for an interface builder level solution, you can create a separate bundle for assets, copy it into your target's compiled sources, and make sure that they are compiled before your app. The way Apple has gone about implementing named colors is in the interface builder is that once they are applied to an element, they get baked into the element's trait collection attributes. So if you have an app and some of the views have their background colors changed dynamically after loading based on some user settings, and if you're using named colors, your code changes will surely be overridden if you're making them in view-did-load method. At runtime, the system will apply that stored value in its corresponding trait collection environment, overriding any code changes that you have made, which means that once they are set in interface builder, the code changes won't take effect unless you change the color one run loop after view will appear. So the solution at the moment is to use view did appear or view did layout subviews methods to override the colors. Now, some of these problems may cause some friction, but they are not insolvable. In fact, named colors have evolved a lot since its inception. I would encourage everyone to leverage this nice feature. Just like we don't like magic numbers hard-coded in our apps, moving colors into color assets means we can be responsive to our designers' needs without having to break a sweat. We can look like heroes. When we talked about semantic colors in earlier slides, we talked about striving to be more, striving for coming up with more generic names. We also talked about that if you have multiple semantics that point to the same underlying color, it is normal. But what about the reverse? What to do when multiple colors have the same semantic name, but in different context? Let's take an example. You need to support 3 different colors with a single button text semantic. How will you go about this problem? Will you create three different variants like button text 1, button text 2, button text 3? Or will you be more specific, like dashboard button text, order summary button text, etc.? How about calling all those with just button text semantic? We can achieve that using namespacing. In general, namespacing is a technique employed to avoid collisions with other objects or variables in a global namespace. By applying the same terminology to colors, you can organize colors in your application into easily manageable groups that can be uniquely identified. Luckily, using this technique, we can hopefully avoid the naming wars. You can provide namespace for assets, but by default, everything has a global scope. Enabling provides namespace option will let you control asset scope via a group name. As you can see in the screenshot, using named colors with namespacing gives us richer semantics. It avoids name collisions and provides intuitive code completions from your editor. Okay, let's talk about dynamic colors. What are dynamic colors? So when your fixed asset becomes RESTful, it's called as dynamic color. Imagine a situation when you want to update the color of an animation in the app for an upcoming holiday season based on certain value that you would receive from your backend. UI color does not conform to codable protocol, but its individual components like RGB values do. You would be able to take advantage of decodable protocol combined with property observers to update the animation color. One area in which property observers in Swift really shine is when we want to configure a view based on a given value. Here, we are using a didSetProperty observer to propagate changes to a color variable received from a JSON down to an underlying animation delegate that's used to render the animation. Okay, let's talk about auto-updating colors. So Matt from NS Hipster has an excellent article about dataset synchronization techniques that you can adopt as part of your release process. In case of colors, you can fetch the color data in the form of JSON and trigger the synchronization from a Slack integration, or maybe create a CD shortcut to do that, or delegate the task to Jenkins or Travis or that bored-looking intern. Storing and retrieving data from asset catalog is trivial. What's actually difficult is ultimately more important, is keeping that data up to date. However you decide to synchronize your data, just make sure it's automated and is part of your release process. An XC assets file is nothing but a collection of folders with JSON manifest documents. These documents describe the assets that are contained within it. In case of named colors, there are no resource files in there either. Designers can easily take advantage of that and be able to create pull requests to add or remove or update the colors in your app. Finally, let's talk about some of the collaboration techniques among designers and engineers. App designers and developers around the world work side by side every day to build some of the most incredible and innovative applications. Yet, their potential for synergy is so often overlooked. Let's talk about simple things we can do every day to benefit from this collaboration. Design handoff remains one of the critical challenges that developers have to deal with. In order to ensure a smooth handoff, both designers as well as engineers must agree upon a consistent asset naming convention and follow that. When using named colors, developers can detect any discrepancies in the naming early on while reviewing the design pull requests. As you're implementing a design, make sure to consistently show it to your designer. Designers love seeing their work come to life, so it's fun for really everybody. Keeping the designers up to date with your progress will help ensure that your implementation is up to the expectations and there aren't any surprises down the road. Proper design specifications allow a developer to see not only the colors, fonts, and measurements of the selected elements, but also the flow of the app as intended by the designer. This saves designers a lot of time by reducing the tedious step of marking all their designs. Instead, the designer can spend more time considering the user experience, while developer focuses on how to implement it. Engineering and design teams could agree beforehand a single place where all of the approved deliverables can be accessed. This would ensure that everyone knows where to go check out the necessary resources. Never underestimate the power of socializing with your team members. Get to know them and let them get to know you. You can accelerate trust and communication if someone feels you care about them as a person, and not just a set of skills that you rely on to realize a design vision. Color deficiency has a far deeper reach than most of us realize. It affects approximately 8% of men and 5% of women all over the world. Apple introduced an incredible color filter accessibility feature in iOS 10. These filters do a remarkable job in increasing the contrast of all the colors throughout the iOS system. Let's talk about simple changes we can make in our apps to help the ones afflicted by color deficiencies. First, strive not to rely on color alone to provide feedback to your users. Certain types of users afflicted with red-green limitations, for example, might not be able to perceive the message indicated with common notions of colors like green is equal to success and red is equal to error. When you need to complement it with other visual cues. Complex, multi-level interfaces may be a real issue for disabled people, especially for those afflicted with vision disorders. That's why it's important to keep it all simple and consistent. You need to be smart about picking out your color combinations. Since color blindness affects everybody in different ways, it's difficult to determine which colors are safe to use in our app design. Having said that, here's a few color combinations to avoid, because they are potential nightmare to colorblind users. The contrast ratio between the text and the background should be no less than 4.5:1. A black and white image, to give you an example, has a maximum contrast ratio of 21:1. You can use tools like Snook or Stark to check your app conformity with the requirement. To recap, be specific about the color spaces when you're communicating colors. Semantic colors can help us design a highly robust color system. The fact that named colors are a feature of Xcode asset catalog means that custom pipelines to generate and synchronize the color palettes are easy to build, which can accommodate a wide variety of team workflows. And always think about inclusivity while designing your apps. As a community and as an ecosystem, we have always strived to make beautiful apps. And we will continue doing that. Settle for nothing less than the whole package. Make your apps beautiful from interface to implementation. And with that note, thank you. Thanks for your time.